The system automatically channels water to crops when the soil is dry and automatically shuts the water supply when the crops have received adequate water. The system is fitted with soil moisture sensors, motorized valves, and programmed computer system which acts as the brain of the system. We therefore propose to pass grey water through the biochar material for several rounds while monitoring the quality of filtered water. It will then be channeled to crops on demand using the already developed sensor-based irrigation system.
Here we have stones, we have gravel pack of different sizes, we have the sand, we have another layer of carbonated charcoal for the purpose of removing unpleasant smell. We have a layer of cotton for the purpose of removing the fat and oil. We have another layer of aluminum sulfate for the purpose of purifying the grey water. And this is the chemicals grey water technology, and all the filtering materials are being packed inside this pipe, which is PVC. Grey water, as it passes through the filtering media, it is collected in a bucket for the purpose of gardening.
Our team is doing research work on coconut and palm waste, and that is where we derive the idea of the char crops wetland system. In the treatment zone itself, that's where we have the char crops. We would also have some plants or macrophytes that will aid in nutrient removal. This technology that we propose is unique because it is energy efficient because of the use of solar power. 2, it's easy to scale. We can easily make it an individual household treatment unit or even for a large community. The char crops in itself can be produced by local charcoal producers, and over time, when the char crops are spent, we can just repurpose this into fertilizer.
Current household grey water treatment systems are either too expensive or inefficient, which limits their adoption. To address this problem, we have developed a proof of concept for a low-cost, efficient household grey water treatment system. Our system is based on a multi-stage filtration process that uses a combination of physical and biological methods to treat grey water. The treated water can then be reused for non-potable purposes, which can save up to 50% of the household's water consumption. The system is designed to be compact, easy to install, and low maintenance. The treated water meets the required quality standards for non-potable uses, such as irrigation and toilet flushing.
En Plantae hemos creado el helofiltro, prototipo del primer humedal artificial prefabricado de alta aireación para tratar de forma intensa y eficiente las aguas grises. En este sistema se combinan procesos de lodos activados junto con biopelículas asociadas a raíces de plantas helófitas. Esto significa que las reacciones de tratamiento se llevan a cabo por múltiples rutas biológicas que garantizan la remoción de carbono, nutrientes y sólidos. El emplazamiento de los elementos de alimentación y recolección de agua le otorgan la versatilidad al helofiltro de funcionar de manera intermitente o continua para producir agua de excelente calidad a costos de inversión y operación competitivos contra otros productos más sofisticados.
Here I propose a two-stage modular biofiltration unit, particularly for water-scarce communities with limited financial and technical backgrounds. Using a combination of sand with the biochar and manganese dioxide as filter buds has been carried out on a pilot scale in my university laboratory, and which showed good results in removing various organic and inorganic pollutants like pharmaceuticals and heavy metals.
In the first stage, grey water is fed to the aerated filter bed. After the first stage filtration, water is pumped and dripped over the second filter bed. After the two-stage biofiltration, filtered water collected in the tank is pumped for drip irrigation of plants. The solar power module attached to the unit provides enough power for the system operation.
In this system, the grey water is collected into an equalization tank, where after homogenization, it is then pumped into the humus bioreactor module using a centrifugal pump. Solar panels are installed on the rooftop of the building to operate the pump and IoT-based sensor placed within the bioreactor. The bioreactor contains a proprietary filter media to accommodate biofilm growth, which facilitate removal of nutrients and organic matter. The organic matter degrades aerobically, producing carbon dioxide, H2O, and new bacteria cells. Humus bioreactor can be heavily customized across urban and rural use cases for grey water treatment and reuse. The energy input required for the system is also marginal.
The vermifilter is a grey water filtration system in which earthworms interact with microorganisms in the degradation of grey water pollution. The vermifilter includes an active zone, here the sawdust, in which earthworms develop, and a filter bed in which microorganisms grow. The filter bed is composed of sand, fine gravel, and coarse gravel as a support layer. The grey water flows vertically through the filter, and the treated effluent is received at the outlet of the filter. Moreover, as another byproduct of the vermifilter, we have the vermicompost made up of worms casting that is also very rich for crops and can be used as a fertilizer.